Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve the questions on network solutions from IES examination. Friends, let us solve question 1. In this question, we are required to find the new time constant if the number of turns of the coil are doubled. We know that the time constant of the coil T is equal to L divided by R. But now, the turns of the coils are doubled. Hence, we need to find the relation between the time constant and the turns of the coil. We know that the inductance L is equal to N squared mu naught into mu R into A divided by L. So, L is proportional to N squared. But the resistance R is proportional to N. So, T is proportional to N squared divided by N. Now, let T1 is proportional to N1 squared by N1. Let T2 is proportional to 2N1 whole square divided by 2N1. By solving, we get T2 is equal to 2 times T1. Hence, option B is the correct answer. Friends, next we shall solve question 2. In this question, we are required to find the steady state voltage across the capacitor if a symmetrical square wave current source is applied across it. Based on the statement of the problem, the circuit drawn is shown in figure. But we know IC is equal to C into dVc by dt. So, Vc is equal to 1 upon C into integration I dt. But by integrating a square wave, we get a triangular wave. Hence, option B is the correct answer. Very simple and straightforward, isn't it? Friends, in this question, we are required to identify the simple equivalent circuit of the given two-terminal network. Observe that an ideal current source of 5 amperes is in parallel with ideal voltage source of 5 volts. In such a situation, understand that the current source will be redundant. To clarify it, the Thevenin's equivalent circuit of the given network drawn is shown in figure. You find that phi Thevenin is equal to 5 volts as this voltage source is directly connected across the terminals A and B, and A and B is open. So, no current will flow through R. To find Thevenin's resistance, the circuit drawn is shown in figure. We find that R Thevenin is equal to R ohms. So, option A is the correct answer. So, friends, remember, when ideal current source is connected in parallel with the ideal voltage source, the current source is redundant. Friends, next we shall solve question 4. It is given that two capacitors are connected in series across 90 volts and after charging fully, they are connected in parallel and we are required to find the voltage across them. As per the statement of the problem, when capacitors are connected in series across 90 volt source, the circuit drawn is shown in figure. The very first concept that you have to understand is current in a series circuit will be same in all the series connected elements that you know. But if the elements are capacitances, then the charge on all the capacitors also will be same. We know Q is equal to C into V. Since 90 volts is applied across the series combination, we need to find C equivalent. We know C equivalent is equal to C1 into C2 divided by C1 plus C2. By substituting the values, we get C equivalent is equal to 40 divided by 3 microfarads. But Q is equal to C into V. By substituting the values, we get Q is equal to 1200 microcoulombs. Now, after charging, the capacitors are connected in parallel as shown in figure. Note that the charge on each capacitor is 1200 microcoulomb. So, when they are connected in parallel, total charge Q is equal to 2400 microcoulomb. Friends, you know, in a parallel circuit, we find the total current by adding all the currents of the parallel branches. It is same as that. Friends, now total capacitance C equivalent is equal to C1 plus C2. By substituting the values, we get C equivalent is equal to 60 microfarads. Therefore, voltage across the parallel combination P parallel is equal to Q total divided by C equivalent. By substituting the values and solving, we get V is equal to 40 volts. Hence, option C is the correct answer. Hope it is clear to you. Friends, in this problem, we are required to find the instantaneous power in a pure inductance for t between 0 to 2 milliseconds when a current shown in figure is applied across it. Remember, average power consumed in a pure inductance is 0. But here, observe the waveform. It is a ramp starting at t is equal to 0 between 0 to 2 milliseconds. So, I of t is equal to m into t, where m is the slope and slope m is equal to 10 ampere divided by 2 milliseconds. By substituting the values and solving, we get di by dt is equal to 5 into 10 to the power of 3 amperes per second. But we know phi L of t is equal to L into di by dt. By substituting the values and solving, we get phi L of t is equal to 15 volts. But we know instantaneous power in the inductance PL of t is equal to PL of t into I of t. By substituting the values and solving, we get PL of t is equal to 75,000 T watts. Hence, option C is the correct answer. Friends, next we shall solve question 6. It is given that a battery of 10 volts with an internal resistance of 1 ohm is connected across a non-linear load whose VI characteristics is 7I is equal to V squared plus 2V. The diagram drawn as per the statement is shown in figure. By writing the Kirchhoff's voltage equation for the circuit, we get 10 minus 1 into I minus V is equal to 0. Or by multiplying by 7, we get 70 minus 7I minus 7V is equal to 0. By substituting 7I is equal to V square plus 2V and simplifying it, we get V squared plus 9V minus 70 is equal to 0. By solving this quadratic equation, we get V is equal to 5 volts or minus 14 volts. But I is equal to 10 minus V divided by 1. By substituting the values and solving, we get I is equal to 5 ampere or 24 ampere. Hence, option B is the correct answer. Friends, finally, we shall solve question 7. Consider the statements regarding the circuit shown in figure. If the power consumed by 5 ohm resistance is 10 watts, then 1 mod of I is equal to root 2 amperes. 2. The total impedance of the circuit is 5 ohm. 3. Cos phi is equal to 0.866. We are required to identify which of these statements are correct. Friends, the problem is very simple but tricky. Read the problem carefully. It is given that the power consumed by the resistance of 5 ohms. I repeat, power consumed in the resistance of 5 ohms is 10 watts. So, we know P is equal to IRMS squared into R watts. By substituting the values of P and R and solving, we get IRMS is equal to root 2 amperes. So, problem statement 1 is correct. By finding the total impedance of the circuit, we get Z total is equal to 15 plus J 15 divided by root 3. Hence, statement 2 is wrong. To test the third statement, let us find cos phi. We know tan phi is equal to x divided by r. By substituting the values and solving, we get tan phi is equal to 1 divided by root 3 and phi is equal to 30 degrees. So, cos 30 is equal to 0.866. So, statement 3 also is correct. Hence, option 1 is the correct answer. Friends, we have solved few interesting questions in this tutorial. During the next tutorial, we shall meet to solve some more problems. Hope this presentation has kindled some of your thoughts. Thank you for watching.